What's up everyone, I am Teacher T, and in this video I'm going to show you that e to the x is equal to this limit here. This is the limit definition of e to the x, the limit as n goes to infinity of 1 plus x over n to the power of n. And I'm going to do that using this very famous definition of e. This is the limit definition of e discovered by Jacob Bernoulli, a long time ago, that e is the limit as n goes to infinity of 1 plus 1 over n to the power of n. I've got a video on this if you want to check that out. I got the link up top and also in the description here. So we're going to convert from this definition of e into this, the limit of e to the x. And you can see the only difference between these two is that there's an x here. And this might be a little confusing why you have an x inside of the bracket when here you're taking e to the power of x, where you'd expect it to be on the outside. So let me show you how this is done. So we'll start here to begin with, of course. This is our definition. And what we're going to do is we're going to take e to the power of x. So that's what we're going to do. So take this e here, take it to the power of x. If we're taking the left-hand side to the power of x, then we've got to take the whole right-hand side to the power of x as well. There, so we just have e in here. This whole limit thing is e. We're taking that to the power of x. And we've got this limit here. I'm just going to rewrite this. This is the e that we had before. And we're going to bring this x inside this square bracket here. If we have a power to a power, then you multiply the exponent. So this is going to be n times x. There we go. Great, perfect. Now we're going to do a little substitution here. We'll make it, let's make it red. So we're going to call this nx and another variable. So we'll call it m. So we'll say let m equal n times x. So if m equals n times x, we can substitute that in there. But we need to find out what 1 over n is as well. So we're going to divide both sides by n. So m over n is going to equal x. And then we'll divide both sides by m. So it'll be with 1 over n equals x over m. Perfect. And again, we'll do our substitution here. This is our e, which we don't really need anymore. But yeah, I'll just erase this. This is our e. And now instead of having an n here, we have an x, or an m. We have an m. So this is m. And instead of 1 over n, right, 1 over n is now x over m. So we got to change this. So rather than 1 over n, we now have x over m. So this is x over m. Perfect. And then one last thing here, we got to change our limit here. We no longer have n going to infinity. We have to change this here. And if you look at our limit as n goes to infinity, what happens to m? Well, m's going to infinity as well because it's proportional to n. So as n goes to infinity, m's going to infinity as well. So we can write this as m going to infinity. Perfect. All right, and if you look at this, this compares exactly, except there's a different variable, but exactly to our initial limit here. And you can write any variable down you want. It doesn't matter. We have some variable going to infinity. I have x over a variable to the power of that same variable, m, and this is, in fact, this is our e to the x here. E to the x. We can proudly write that. So e to the x is equal to this limit as m goes to infinity of 1 plus x over m to the power of n, based out of our definition, the definition of e. Right on. I'm Teacher T. Thanks for watching. See you in the next video. Cheers.